Hello students, welcome to my channel Engineers Academy. Let's solve this one another problem from this distributed loads topic. So we are given this cantilever beam and it is subjected to this parabolic distribution of load which is symmetrical about the middle of the beam, right? And it is said that determine the supporting force Ra and moment Ma acting on the beam at A. So we have to determine the supporting forces Ra and Ma on the beam at this particular point A, right? We have to find the reactions at this point A. But before going to solve this, we have to find this parabolic function, right? So let's say that this curve is, let's say, w of x function, right? So we have to find this w of x function, right? So as we know that since it's a parabolic curve and the general form of the parabolic curve is, since it's a second degree curve, so its general form is ax square plus bx plus c. So first we have to find these constants a, b and c, right? Then we will be able to find the resultant of this distributed load, which is represented by this parabolic distribution load, right? If we define our coordinate system, right, at the middle of this beam, right, if this is my positive x-axis and if this is my y-axis, on y-axis we have that w of x function, right? We have plotted the w of x function, right? So we are given these three boundary conditions, right? Here at x is equal to 0, we can say that at x is equal to 0, w of x is equal to omega naught. This is given, right? At x is equal to 0, this parabolic curve has a value of omega naught, right? So now if we put this x is equal to 0, this boundary condition in this equation, right? This is our main equation. Let's say this is equation 1, right? Or we can say that, let's say this is equation A, right? So if we put these values in equation A, so then we can write that this is omega naught equal to ax square, so a into 0 plus b into 0, x is 0, right? So this is plus c. So this means that c is equal to omega naught, right? So this is one constant in that equation A. Similarly, we can see that at x is equal to plus L divided by 2. Here at this particular point, when x is equal to L divided by 2, from this origin, the function value is 0, right? That is omega x equals to 0, right? So now if we put these two conditions in that equation A, so we can write that 0 equals to a into L divided by 2 squared plus b into L divided by 2, and we know c is omega naught, right? So this is a L square divided by 4 plus b L divided by 2 plus omega naught equals to 0. We can say, we can write this equals to 0 on this side, right? So now if I multiply this whole equation with 4, so we will write that this is a L square plus 4 into b L divided by 2 is 2 b L plus 4 omega naught, and this is equal to 0. So let's say this is equation 1. And we have one another boundary condition at x is equal to, we can write that at x is equal to minus L divided by 2. Then at this particular point, again that function has a value of 0, right? So this omega x is 0, right? So now again we can put these two values in that equation A, right? So we can write that this is 0 and this is A, and this is minus L divided by 2 squared plus b into minus L divided by 2 plus c, and c is omega naught, right? So we can write that this is A, this will become L square divided by 4, and this will become minus b L divided by 2 plus omega naught. This is equal to 0, or we can say that this whole equation is equal to 0. Now if I multiply this whole equation with 4, so we will be left with a L square minus 2 b L plus 4 omega naught, and this is equal to 0. So this is equation 2. Now if I add equation 1 with 2, right? So we can write that equation 1, this is equation 1, a L square plus 2 b L plus 4 omega naught, this is equal to 0, right? So this will cancel out. So we will be left with 2 a L square plus 8 omega naught is equal to 0. And from this equation we can write that 2al square is equal to minus 8 omega naught, and we can find this a constant, right? So this is minus 8 omega naught divided by 2l square, and from this we can write that a is equal to minus 4 omega naught divided by l square. So this is that a constant in that equation A. Similarly, we can find this b by using either equation 1 or 2. So if I use equation 1, so in equation 1 we have al square plus 2bl plus 4 omega naught, this is equal to 0, and now we know that a is equal to this thing, right? So we can write that this is minus 4 omega naught divided by l square, so l square will cancel out, right? So we will be left with minus 4 omega naught, right? Or I can write it here. So we will be left with minus 4 omega naught, and minus 4 omega naught plus 4 omega naught will become 0, right? So we can write this is 2bl plus 0 equals to 0, or we can say that 2bl equals to 0, and from this we conclude that b constant in equation A is 0, right? So now we can put these a, b, c values in that equation A, and that will be the equation which will define this parabolic curve, right? So we can write that w of x is equal to ax square. So a is minus 4 omega naught divided by l square into x square, right? We are putting a, b, c values in this equation A, right? So this is ax square plus bx, so b is 0 into x, and c is omega naught, right? So we can add this plus omega naught, right? So we will be left with minus 4 omega naught divided by l square x square plus omega naught. This is that w of x function. So now the next step is that we need to find the resultant of this distributed load, that concentrated resultant which will replace this distributed load, right? So what we will do is that we will select a differential area, right? So for that I will select a differential area somewhere here. Let's say that this is our differential strip, and this differential strip is located at a distance of x from this origin, right? And this height is omega x, right? And this thickness is dx, right? So we can write that this, let's say that this differential area represents that differential resultant of the differential distributed load which is associated with this area, right? So we can write that this represents this very small resultant of that distributed load, right, which is associated with this very small area. So we can write that dr, right, r represent that resultant, right? So dr will be equal to omega x into its thickness, right, dx. Its thickness is, this thickness is dx. So I will multiply this with dx. So now if we integrate this, so we will get the resultant, right? And this equation will find the area under this curve, right? And that area will represent the concentrated resultant load which is associated with this distributed load which is defined by this w of x function, right? So now this d will cancel out, so we will be left with r, and we know omega x function, which is minus 4 omega naught by l square into x square plus omega naught dx, and we have to integrate this from minus l divided by 2 to plus l divided by 2, right? So this is minus l divided by 2 to plus l divided by 2, right? So now if we integrate this, so we will get minus 4 omega naught divided by l square, and this will become x cube divided by 3, right? And this will become omega naught x, and this is from minus l divided by 2 to l divided by 2. So now if we put these boundary conditions, right, so this is minus 4 divided by 3 omega naught by l square, and this is l divided by 2 to the power 3 plus omega naught into L divided by 2 minus 4 omega naught divided by 3 L square, and now we have to put minus L divided by 2, and this is plus omega naught minus L divided by 2. So from this we get minus 4 omega naught divided by 3 L square. This will become L cube divided by 8. 2 to the power 3 is 8. This is plus omega naught L divided by 2. This will become a minus into minus, plus into minus minus, and this is 4 omega naught divided by 3 L square, and this will become L cube divided by 8, right? And this is minus, this become minus omega naught L divided by 2, and that minus multiplied by this minus will become positive, right? So this is omega naught L divided by 2. So as we can see that both of these terms are similar terms, they will add up. So now we will add up both of these terms, right? So this is 2 times, right? So we will write that this is 2 times minus 4 omega naught divided by 3 L square into L cube divided by 8, right? And similarly both of these terms are similar terms, so there will also become 2 times, right? So this is 2 into omega naught L divided by 2, right? And as we can see, if this will if I multiply this, and this will cancel out, L square will cancel out, so we will be left with 1 L, right? This 2 will cancel out, and we can write that this will become 2 into 4, and 4 will cancel out, right? So we will be left with minus omega naught L divided by 3, and this is plus omega naught L, right? Only omega naught L, and if we take omega naught L common, so this will become minus 1 divided by 3 plus 1, and minus 1 divided by 3 plus 1 is 2 by 3, right? So we can say that that resultant is equal to 2 divided by 3 omega naught L, right? So we can replace this distributed load, which is a function of, which is a parabolic function, which is represented by this function, right, can be replaced by this concentrated load 2 divided by 3 omega naught L. And as we can see that this distributed load is symmetrical about the mid length of this beam, right? So we can say that by inspection we can say that this R resultant will pass through the centroid of this area, and that centroid of this area will be located on this y-axis is somewhere, right? So then we can say that this R will be located at the midpoint of this beam. The line of action of this R will pass through the centroid, and since the area is symmetrical about this line, so the centroid will be located on this particular line, right? So then we can draw the free body diagram, right? So this will be our free body diagram. This will be my beam, right? This is that point A, and at this point A, we will have a X reaction, we will have a Y reaction, and we will have the moment support as well, right? So let's say this is MA, right? And at the midpoint of this beam, we will have that resultant, right? This is that R, which is represented by 2 divided by 3 omega naught L, and this length is L divided by 2, right? So now if I apply the summation of moment about point A equals to 0, so as we can see that this MA is acting in the counterclockwise direction, so I will write plus MA, and this R is producing the clockwise moment, so I will write minus 2 divided by 3 omega naught L into this L divided by 2, and this is equal to 0, right? So we can write that this MA will be equal to minus, this 2 will cancel out, so we will be left with omega naught L square divided by 3, and this is equal to 0, or we can say that that MA moment support is equal to omega naught L square divided by 3. And similarly, if we apply the summation of forces along x equals to 0, so as we can see that only this AX is acting in the positive x direction, and there is no other force in the x direction, so this means that AX is equal to 0, And similarly, if we apply the summation of forces along y equals to 0, so as we can see that this Ay is acting in the positive y direction, right? This is, if this is our positive x and y direction that we have defined already, right? So Ay is acting in the positive y direction and this r is acting in the negative y, so I will write minus r, and r magnitude is equal to 2 divided by 3 omega naught L equals to 0, or we can say that Ay is equal to 2 divided by 3 omega naught L. And if we want to find the total resultant reaction at point A, so let's say that Ra is the total resultant reaction, so this will be equal to Ax square plus Ay square, and then we have to take the square root. Since Ax is equal to 0, so this means that our A magnitude will be equal to Ay magnitude, which is equal to 2 divided by 3 omega naught L, right? So this is the reaction at A, and this is the moment reaction at point A. So this is the solution of this particular problem. I hope you people would have understood this problem solution. Kindly subscribe my channel if you are new to my channel. Also like this video if you want me to solve such more problems.